we have a very dynamic generation mix, we need a dynamic transmission system. And so we're faced with two challenges: making sure that we have a transmission system that can answer the call when we ask more from it, but also that we're utilizing the existing transmission that we have as efficiently as possible.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about getting the most out of our transmission system. I should know I spent several years upgrading transmission in the Carolinas. Compared to the somewhat disposable equipment I encountered in my oil field days, transmission infrastructure is built to last. Some substation breakers coming out of service were older than the moon landing. Transmission lines are another critical part of the system. As my guest points out, we're asking of them much more than was ever envisioned. The decades-long model of a web of large-scale generation surrounding the grid is giving way to rooftop solar, battery storage, and smaller generation like natural gas. You also have generation like wind coming from distant pockets of the country to urban centers. I remember back in Texas how a coal plant in the northern Panhandle area was being asked to curtail power to give way for new wind generation because the power lines didn't have enough capacity yet. This wasn't a CO2 issue. Texas needed power from that coal plant. There simply wasn't enough room on the line. This phenomenon is called congestion, and if the line is deemed congested, you have curtailments. For businesses, this means cutting off the power. In the case my guest describes, generation can also be curtailed, which exasperates the problems. My guest says that this congestion is essentially based on preordained limits called a static rating. The amount of electricity going through the line isn't the problem, it's the heat and sagging that can result. Without real-time data, it could be possible that the line is not in danger of melting down as you'd think. Wind could be cooling the lines down, for instance. It would not be irresponsible, therefore, to push the lines a little further, using this real-time data to ensure they are being operated at a safe level. And it's worth it, according to my guest. We discuss a case study that shows as much as $8 billion is lost annually due to curtailment that did not need to happen. My guest says over 90% of the lines aren't truly congested at the time these curtailments occurred. He says it's time for real-time data to ensure the lights always shine and clean energy always flows. My guest today is Alex Hodeling, Vice President of Sales for LineVision, a line monitoring company based outside of Boston. LineVision has a product that combines LiDAR with an electromagnetic field sensor to capture real-time data on transmission lines. These sensors can also detect sagging of lines to ensure their health based on historic reference images, for instance. I'll admit I played a little catch-up during this interview. Reading the literature, I thought the company could tell when a line was congested. LineVision's value is that they can tell when a line is not in fact congested. I'm sure you can spot the point where a light bulb goes off over my head. I hope you enjoy my conversation with Alex Hodeling. We're here with Alex Hodeling, Vice President of Sales for LineVision. And Alex, first questions first. Let's help our listeners understand. What are some things that are typically monitored on power lines?
It's a good question, Jay, because the short answer is not much. Utilities will typically do periodic inspections for things like vegetation encroachment or clearance to ground to make sure there aren't any violations with that. Sometimes they will cut a piece out of the conductor itself and send it to a lab for inspection to make sure that the conductor is healthy. But I would not categorize that as monitoring. That's really more of a snapshot of the lines. What LineVision is doing is continuously monitoring these lines. So it's very different than what we're typically seeing right now, but it's needed. You think about the grid at large, the transmission lines themselves are the backbone of that grid, and they tend to be the things that are monitored the least. Yet utilities are incredibly comfortable with monitoring technology. I drive past the substation for my local utility on a a daily basis. And even though I know a whole lot about the energy industry, I could probably only name half of the things that are in there with all the technology. So monitoring is fully accepted and adopted, but it's time for power lines themselves to receive that level of attention.
Yeah. And look, I've spent some time in the transmission sector. From time to time, the guys in the field would shoot infrared on the lines, the transformer, other apparatus, just to make sure it wasn't too hot. So does your equipment do that constantly?
That's a good way of looking at it in the sense that it is constant. But those guys that you mentioned who were shooting a laser to see how hot something was, were really doing that for the safety of the equipment. They were just looking at half of the equation, so to speak. They were making sure that something wasn't too hot. But they weren't looking at the available headroom that was present when that equipment was actually cooler. In the case of transmission lines, most of them are thermally limited. So understanding the temperature of those conductors tells us, again, not just what it means to have safe operation, but what the available headroom is or available capacity that could go on those lines. And so, yeah, you have it right. We're doing it continuously, but we're not just doing it to make sure that it's safe. We're also doing it to make sure that you have more capacity available.
And what is your equipment specifically monitoring for?
We use a combination of LiDAR technology and an electromagnetic field sensor. And what we're doing is we're angling the LiDAR at the conductors themselves. And we're using that very specific information about the position of the conductors to understand the relationship between the sag of the conductor and the temperature of the conductor. We're creating a scenario where by understanding the line's specific position better, we're gleaning information about, like I said, the temperature, but also the situational awareness component to make sure that there isn't any potential impact with vegetation, to make sure that if there are things like conductor slap, when some conductors are coming together and potentially causing a wildfire, that we're able to mitigate that by knowing the precise location of the lines with LiDAR.
Alex, if I understand it correctly, you're constantly monitoring lines with LiDAR. So there's always some LiDAR sensor on all of these miles of lines. That sounds like a lot of LiDAR. It sounds expensive. So help us understand how much kit is being used here.
When you think about what's really in play here, we're at a moment in history where we're talking a lot about infrastructure and the need to consider the fact that most of the lines that are hanging in the air right now were strung 50, 60, sometimes even 80 years ago. They're the same physical lines that are hanging. And so we're faced with two challenges: making sure that we have a transmission system that can answer the call when we ask more from it, but also that we're utilizing the existing transmission that we have as efficiently as possible. Really, you're looking at roughly 5% of the unit cost to monitor a line. Certainly, new transmission is needed right now, but we need to make the most of what we have and make sure that we have a grid that is as flexible as possible and as nimble as possible. Because when you think about the task of building out this grid to incorporate more renewable energy, to handle the challenges that we're asking it to face, sometimes these projects take 5, 10, 15 years to actually complete. Whereas if you were to deploy dynamic line ratings, which is what LineVision does, that could be deployed within a matter of months. So absolutely, Jay, cost is a factor and it's a consideration, but we also have to look at the overall efficiency of the grid itself.
I'm going to ask you a real geeky question here. How are these sensors powered if they're on top of a 500 kilovolt tower? Is there a service transformer?
Yeah, it's a great question because the mechanics of it, so how it actually works and where it's placed, means a whole lot to the utility. Because if you ever have to put something on a conductor itself, it's very risky, it's very expensive. But the great thing about LineVision's technology is that nothing whatsoever touches any conductors. It's fully self-powered. It's powered via PV, and the unit itself has a CPU inside it that does the light processing of the data, and then it's sent via secure LTE to the cloud, and then it's available to our customers.
You mentioned LiDAR. Would you put a LiDAR sensor on every single tower, or can it scan like a couple of spans?
Yeah, that's an important thing to consider. So the short answer is no, we would not put it on every tower. What we believe is that within 5 years, every line will be monitored, but every line does not mean every tower. You only need one monitor for roughly every 4 miles. And it depends on the heading of the line because wind has the greatest impact on the cooling of the line. So as you have orientation changes of the line, we need to make sure that we're capturing how the wind is hitting those different parts of the line. But if you had a straight shot, 4 miles, 1 monitor is sufficient. But we would scope the line prior to any installation well in advance to make sure that we're capturing everything that needs to be captured, but definitely not every tower.
Yeah. Alex, I've had a little bit of experience with LiDAR with transmission. For instance, I once saw it used on an application on the right-of-ways for transmission lines where the data that was captured by LiDAR could then forecast when certain trees would grow too close into the lines and towers. I think they were attaching a LiDAR sensor to a helicopter and just running the span of the right-of-way, right? And I think ultimately they would try to do it with drones. Could you be doing something like that with it? Or are we just trying to monitor the health of the lines at this point?
Yeah, it's a good question. LiDAR isn't new. That's very well understood. In fact, if you have an iPhone, you have LiDAR on your iPhone right now. And you're right, you can attach it to a helicopter and fly the lines. And that does give you a snapshot in time of where the conductors are relative to vegetation, for example. But really the theory that underpins LineVision is that isn't sufficient to give you the data set that you need to understand your lines and to make sure that you're monitoring and managing them safely and effectively. Instead of attaching it to the helicopter, we're attaching it to the tower itself and in perpetuity looking at that positioning of the line. And we hear a lot about dynamic line ratings, and that is receiving an enormous amount of attention from the market, from regulators. That's a key application that we deliver, and that is related to the sag of the conductor, the relationship between sag and temperature. That tells us how much more capacity that you can put on that line. But we're also using LiDAR for real-time situational awareness in the case of wildfire risk mitigation, looking at the propensity for conductors to move asynchronously and come together and have what's called conductor slap, where they drop molten metal onto the ground and start a fire. We're looking at things like icing, where you need to have a good understanding of the damage that could be caused to the lines. So that real-time situational awareness is driving a whole host of applications for utility, a whole host of use cases, which is really important. And then the third application we have is for conductor asset health. So it's looking at that relationship between sag and temperature and also incorporating some historic data and understanding what the likelihood is that elongation has occurred on the line, that max operating temperature has been exceeded, that annealing has happened on the line. There are lots of applications, and it's all coming from LiDAR. That same unit that's attached to the tower is driving all of those applications at once.
Yeah, before this interview, I read a case study about your technology that mentions that congestion on power lines costs about $8 billion in annual losses. Now, I assume that means losses for the utilities. I know utilities are monitoring these lines on the substation level. So why would it matter to physically monitor the lines? Wouldn't the substation data, wouldn't you be able to tell that there was some sort of loss going on between the substations?
Sure, it's a great question. So the first thing I'll say is that $8 billion in annual losses, it's not the loss to the utility. Depending on where you live, that's a loss to you. So Jay, that's coming out of your wallet because that congestion is everyone's problem. In terms of the substation versus the lines themselves, there's a lot of technology that can tell you where congestion is, but the next natural question is, well, what do you do about it? And unless you have a more granular data set that includes looking at the lines themselves, you might know congestion exists, but how to mitigate that, how to alleviate that, that's another story. And that's where we come in. Just to simplify this a little bit in terms of what dynamic line ratings are, pretend you were a civil engineer and it was your job to decide how many cars could fit on a highway before a traffic jam occurred. If you didn't incorporate real-time conditions, you would likely base your answer around how many cars can fit on a highway on a worst-case scenario. Where I live might be a snowstorm, it might be a rainstorm somewhere else. If you did that, you would be drastically underestimating the amount of cars that could fit on the highway when the conditions were better. To complete the analogy, utilities are the same. Utilities set what's called a static rating. It's that level that they can't cross, and it tends to be based on a worst case scenario that doesn't fully account for the impact of wind cooling the line. What that means is utilities are being conservative, as they should, and planning for a worst case, but by not incorporating the real-time conditions, that wind on the lines, we're just not having the amount of capacity that we could. And that's why so many lines are congested. That's why it's an $8 billion a year problem. And it's my belief that $8 billion is fictitious, that congestion doesn't need to exist. Generally speaking, speaking, in the high 90% of the time, you're finding scenarios where there is more capacity that's just purely going untapped. This congestion is something that can be addressed today.
So this idea of congestion, and I assume you're talking minute to minute, right? Not a line being flawed. This is something I really don't even understand. What can utilities do when data shows a line is congested on a certain day?
Well, if a line is congested, they're going to have to do curtailments. That's the scenario that exists right now. The reason congestion is important is because these are physical assets. And if you heat a line past its maximum operating temperature, you run the risk of damaging that line, and it can't be repaired. These are aluminum and steel lines in most cases. And once annealing has happened, you're changing the chemical structure of the asset itself. It can't be repaired. But in many cases, there's far more capacity than they are able to use because that static rating is too conservative and it doesn't take into account the real-time conditions. This is not a minute-by-minute situation where you would need somebody constantly dialing up capacity, dialing back capacity. There's a thermal constant to overhead lines. And so the temperature of a line isn't going to drastically change within a 15 to 20 minute period. What we would do is look at the rating of the line and understand with a forecasted methodology, be that 24 or 48 hours out, saying, okay, what do we anticipate is the available capacity that will be on that line? And then operators can plan based on that. So it's right to ask, is this minute by minute? But the reality is it's not. It's something that can be far easier to control.
And so they can take real-time data. And then what would be an example of an action that they would take?
Sure. Let's use the case of a wind farm, and there is congestion on the lines. It's not able to have those electrons from the wind farm put on the grid. As that line becomes congested, the operator will say, okay, we have to, in effect, shut down the wind farm because we don't have the capacity to put those electrons on the grid. Returning to the highway analogy, it's kind of like saying, look, the HOV lane is closed, so we have to limit the amount of cars we put on the highway. But the reason I use the wind farm example is because wind is something that obviously turns the blades of turbines and creates electrons, but that same wind is also cooling the conductors. There's this perfect scenario for wind farms in particular, where you have the wind creating electrons, but also cooling the lines, making more capacity available. It definitely bothers me when the wind is blowing and I drive past them and they're not spinning. It's a direct manifestation of congestion, and that's something that we can solve. This is technology that exists. It's deployed, it's out there, it's ready. It's just very dispiriting to see windmills not creating electrons when the wind is blowing.
And so what was happening in the past was the line would get over congested and the utility wouldn't know about it?
The utility will know about it. It's what they do about it that matters. If you're having curtailments, then you're not making the system operate as efficiently as it could. But if you are aware that you have more available capacity, you wouldn't need to have those curtailments. What that DOE study showed is that these are not high increases in capacity that lead to, in effect, a complete alleviation of congestion on the grid.
So what you're saying is that the data may be showing that the lines are getting congested, but external factors such as wind blowing on the lines show that the line isn't as in danger of being congested as it might be. Is that the idea?
Yes, that's correct. And I'll return to the highway analogy. If you have 1,001 cars trying to get down the highway, you're going to call that highway congested. But if you realize that actually there's a whole other lane that you didn't even realize existed, instead of handling 1,000 cars an hour, you're able to handle 1,500. Congestion is something that we often create based on the rules that we set. But if we have a more real-time understanding of the true condition of the conductors, we're able to alleviate that congestion and get those electrons moving.
Alex, I once spoke to a company, Smart Wires, that claims to have a valve technology that they would put on transmission lines. And the big point of that technology was that it would be easier to incorporate renewables and more distributed generation. Now, utilities are moving into a new era with all of this. How is more real-time information on the lines critical for that? I think the idea that you've got a lot of different sources of generation coming into play. It's not as predictable as it used to be, right?
It's well said, Jay. The generation mix, the generation stack, as we call it, is much more dynamic than it has ever been. We no longer have centralized generation spreading out like a spider web. We have distributed generation. We have renewable generation that's often in very rural areas, and it needs to get to the grid. And that's not always easy. When we have a very dynamic generation mix, we need a dynamic transmission system. And right now we don't have that. We have more of a traditional traditional system that was designed 150 years ago. And we need innovative technology, what we call grid enhancing technologies, that can step in and say, look, we need to be able to look at that with fresh eyes and say, look, these are some technologies that exist that can make it more efficient, that can give us relief on the system today. You mentioned smart wires. It's complementary technology to LineVision's technology. Smart wires, to grossly minimize what they do, which isn't fair, but it's the GPS of the energy system. If one part of the system is congested, the GPS is going to reroute you around a different path. Smart wires is designing their system to give you that best route, but what LineVision is doing is making sure that all of the routes collectively have the least congestion as possible.
One of the things I love talking to, especially the head of business development, is tell us how we're doing. Where have you had the most success, and where do you think you can expand?
Sure. LineVision recently celebrated its 3-year anniversary. We're very proud of the strides that we have made and what we're building in this company, because it's this perfect alignment of technology and market forces that create a scenario where it's really the exact right place at the right time. Everything that we're all hearing, and if you're listening to this podcast, you know a lot about the current energy dynamics going on and infrastructure planning, and really how urgent these types of technologies are. So we're really proud of what we built and very lucky to be at a place and time where, like I said, this technology is meeting the market at a perfect time. LineVision completed its Series B earlier this year, which was really rewarding for us. We know what we're building. We know the capabilities. We know the customers we have are happy, but there's something about people voting with their wallets and fighting to be given the privilege of giving you investment dollars. And they scrutinize us a lot. They make sure that this is technology that is going to transform the market. The business side of things aside for a moment, what we really believe in at LineVision is that what's going to make the difference on the grid, what's going to make the difference with this energy revolution is not just hardware, it's information. And we consider ourselves a data science company, first and foremost. That's the largest category of people we hire. They're all a lot smarter than I am, which keeps me humble, but it's a great group of people. And we have great customers. In fact, several of our customers alone account for over 25% of all the transmission miles in the United States. We're working with 6 of the top 10 largest utilities in the US. And for anyone who has ever worked with utilities, you know that they're conservative, you know that they're cautious, and they make their decisions very carefully. But it speaks to the fact that the challenges that exist on the grid are not the US problems alone. These are global challenges. When we think about some of these macro issues, whether it's incorporating renewables and the resulting congestion, better managing aging assets like overhead conductors, these are global problems. And that's why we're taking a global approach to bringing this technology to market.
Well, that's really exciting that you have such large customers like that. And one of the things I would think is that any customer that would commit to this system where you're essentially adding LiDAR onto the transmission lines where you can get real-time data, I would imagine that that's turned in some situations into a very collaborative effort where they're like, look, yes, the lines is important to know, but what about the insulators? What about the structural steel of the towers? Like I mentioned earlier, what about being able to monitor vegetation that's grown so you don't always have to do tree cutting? You can minimize the amount that you do on that. Surely there's been collaborations on new kinds of software that interact with the utility. How have those collaborations been?
Yeah, they've been great. And, you know, we take a very collaborative approach to working with our customers. And some of the best ideas actually come from our customers. We'd love to take credit, but really, I think the fact that our customers are so engaged in helping us grow is really speaking to the fact that these problems are significant, but also require creative minds, require very innovative spirit. We have no monopoly on those things. That exists everywhere. The fact that we're able to work so closely with our customers is creating a breeding ground for innovation. And I think that's what allows us to move forward with our customers. You know, frankly, the data that we provide for lines is incredibly valuable. But the moment we deliver it to our customers, it instantly shines a flashlight on the areas where they don't have that same information for other lines. By giving them this type of access, they realize, wow, we need this everywhere. This is something that can really change how we manage our grid, how we can incorporate more renewable energy and solve some of these very thorny challenges that we have. So yeah, it's been a wonderful process. Being able to work so closely with our customers is really what gives us a lot of energy.
All right, Alex, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Natural gas is necessary. It's growing, which makes it unique among fossil fuels, but it's volatile.
Crude oil.
Again, necessary. I think that crude oil is what gets us from point A to point B, but I'm also very interested in what's coming with electric vehicles.
Nuclear.
It's a hard choice. It's our nation's third largest source of generation, I believe, but it's now behind renewables. I think that's very telling. It's right now necessary, but it also has disconcerting aspects, as everyone is well aware.
Coal, and I'll add coal with carbon capture.
Coal is, I think, emblematic of the energy transition. It was, and in some places remains, the bridge to an electrified world. But there are many places where we've gotten across that bridge. And I think the story of coal should not be a political one. It should be one of a successful transition to a less expensive, cleaner future.
Wind
has huge promise. There is some short-term pain. I think that if you think about the fact that in the past 20 years, there's been, I believe, a 50x or so increase in the capacity of wind in the United States. That alone is an enormous success story. But for wind to take that next approach, I think it's going to take political will. The technology is there, but it's going to take the political will to make that happen.
Solar.
I think solar is similar to wind in the sense that it does take political will. There are a lot of places within our country where solar could be deployed much more broadly, and it's not being, and that's frustrating. It also has the added challenge of being behind the meter. But again, with all sources of renewable generation, the short-term challenges should in no way overshadow the fact that this technology is ready and can play a huge role in the energy transition.
Biofuels.
I think biofuels, your opinion depends a lot on what your opinion of electric vehicles is. I think if you're bullish on one, you might be bearish on the other. I think it's a important transitional technology, but I tend to be very bullish on electric vehicles.
Hydroelectric.
Incredibly stable, hasn't moved in terms of its generation mix in decades. That said, it's becoming more volatile with climate change, but still remains a very important technology.
Geothermal.
Limited for generation, very interesting, but very geographically specific. I'm more interested in geothermal for heat pumps. I think there could be a great story for energy efficiency there if more broadly deployed.
Energy storage.
I think energy storage is very important for the energy transition, but it depends on how distributed it is. I think the more distributed it is, the more impactful it can be. And I keep coming back to electric vehicles. In effect, I think that's going to be the greatest source of energy storage that the world has ever seen.
Electric vehicles.
Electric vehicles are generation in a bottle. I think it's incredibly exciting technology. I think the ability to have consumer choice with how your vehicle is charged and powered is something that's a very good thing for the consumer, and obviously could be much cleaner and just really fun technology. That's amazing.
Energy efficiency.
I think energy efficiency historically has received an unfair bad reputation. And I think that's maybe a mindset we tend to have as humans, aligned at least mentally with people giving something up instead of using resources more wisely. And I don't think that's the case. I think energy efficiency is smart. I think there's technology that exists that can help make buildings much more efficient. It's ultimately an incredibly important part of the energy transition, but it needs a really concerted marketing effort, I think.
And then finally, fusion power, nuclear fusion.
I think fusion power is exciting because we're able as a country and as a global market to look 30 years out for how our future is going to be powered. And, the promise, I think, of fusion power is far away, but the fact that we're able as a nation and as a world to dedicate resources to figuring out how we can power our future is very encouraging.
All right. Alex Hodling, LineVision, thank you so much for your time.
Thank you, Jay. It was a pleasure.
That was Alex Hodling, Vice President of Sales at LineVision, a Boston-based overhead line monitoring solutions company. Alex says a DOE report shows that 60% of all curtailments could be eliminated if line capacity was increased just 5%. Congestion could be essentially eliminated entirely if there was a 10% increase in capacity. And based on LineVision's findings, most lines can go far beyond that. I want to thank Alex for his time, as well as Colin Mahoney at Mahoney Communications for setting this up. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 120. Be sure to join us next week when we check out a new utility-scale battery storage technology that will remind you of old times. Until then, I'm Jay Downhauer. We'll see you next time.